for our distinguished leader, engineer, submariner, and teacher, keynote speaker, Rear Admiral Pete Small.
Okay, thank you, Jennifer, for that introduction, and thank you, Molly and SENEDIA, for inviting me here to be with you all today. It's a great pleasure to be here at SENEDIA and at this event. It's great to try to connect with the audience in these events, and so I've been explaining to people that this is familiar territory for me. I've lived outside of Boston for 5 years on 2 separate occasions, and in East Lyme, Connecticut for 3 years, working with some other industry partners here in the front row. And I wish I had a tally for all the times I've flown between Reagan National Airport and Providence in coming to either Newport or the Groton waterfront or Quonset Point. It'd be an impressive number, but unfortunately I haven't been keeping those statistics. So I'm happy to be back here. It's just like coming home, and thanks for inviting me. Okay. I've been the chief engineer at NAVSEA for about a year now, and as you heard earlier this summer, I assumed command of the Naval Surface and Undersea Warfare Centers. So I'm going to talk about that a little bit today, but I'd like to leave you with a message that talks about teamwork and urgency. True maritime superiority hinges on seamless teamwork between the Navy, our industry partners, and academia. And this collaboration is the engine that's driving the development and delivery of the capabilities that our nation demands. Critically, we must also cultivate a relentless sense of urgency. Maintaining our competitive edge requires rapid technical innovation, demanding that we act decisively and without delay. Only through this urgency can we secure our enduring maritime advantage. So the teamwork I'm talking about requires open communication, sharing knowledge and information freely, and proactively helping each other succeed, just like events here today, like SENEDIA are helping us do. It's about breaking down silos and viewing ourselves as one united force. Urgency isn't just about rushing, though. It's about prioritizing and acting decisively. This integrated approach will enable the rapid deployment of next-generation systems, from autonomous vessels to resilient communications networks, and ensuring that our fleet remains lethal, adaptable, and ready to face the evolving threats of the day. That sensibility is critical in this moment of history. As you know, yesterday we got our new CNO, Admiral Caudle, sworn in, and I wasn't so agile enough to get those remarks from yesterday worked into my speech, but earlier he testified in his confirmation hearings that years of shrinking fleet size and diminished shipbuilding capacity and on-time repair delivery execution have manifested themselves as persistent challenges previously masked by unquestioned naval supremacy throughout the decades. To continue to outpace our adversaries, we must turn them with thoughtful approaches to warfare, harnessing innovation to take longer strides, relying on the ingenuity, skill, and brilliance of our American workforce and our reimagined industrial base. Only then will we continue to be a Navy that is lethal and survivable, but also adaptable and sustainable. We must adopt and deploy new technology faster than our competitors and optimize how NAVSEA and our industry partners deliver technology and engineering solutions to the program offices, depots, and fleet customers in support of our national priorities. Then we can deliver a ready and capable fleet whose systems are integrated, affordable, and effective. So I'm going to talk again about NAVSEA and the perspectives on this national challenge. So my boss, Admiral Jim Downey, has focused on 5 priorities in support of the CNO's call and our national imperative. Those are accelerating force generation, generating readiness, using data to drive innovation, strengthening the NAVSEA workforce, and enhancing our critical infrastructure. So I'm going to talk about that now from kind of my NAVSEA 05 Chief Engineer hat and also the Warfare Center hat, but first as the Chief Engineer. So NAVSEA 05, or the Engineering Directorate, delivers engineering for all U.S. Navy warships and systems across the full system lifecycle, from requirements development through design, construction, and modernization to disposition. We ensure they're designed and built to perform, to last, and to maintain their warfighting edge against the evolving threats of today and tomorrow. We generate unique value through our technical expertise, cross-portfolio management, historical knowledge, and continuity. We engineer the Navy's ability to continuously forward deploy lethal and combat-ready warships. CO5 is comprised of many of the nation's foremost experts in warship engineering disciplines, from corrosion control and propulsion systems, hydrodynamics and survivability, to ship design and combat systems integration. CO5 touches every ship and submarine and the combat and weapon systems they employ, from design to construction and through in-service and disposition. CO5 is responsible for providing engineering solutions across the entire life cycle. We also serve as the Navy's systems engineering organization, exercising technical authority, managing risk, and providing the technical rigor required to ensure warfighting readiness and effectiveness. As of June, I'm also the Warfare Center commander, both the surface and the undersea warfare centers that are comprised of 10 geographically dispersed divisions that make up over half of the Navy's engineering and scientific expertise. One of those divisions, as you all well know, is right here at the Naval Undersea Warfare Center Newport Division, a critical center of gravity for delivering undersea warfighting capability. Newport and its sister divisions are the principal research and development organizations for NAVSEA, critical in developing and executing the engineering solutions we provide and delivering sustainment to our fleet. They are a vital link between the technical community, industry, and our sailors and Marines. This dual hat I now wear as both the Warfare Center Commander and the Chief Engineer was a strategic decision by Admiral Downey at a time when the national demand for a fleet is high, our industrial base is challenged, and our workforce is smaller and less experienced than it has been in the past. There's no lack of evidence that or dialogue for that matter, about the Navy's challenges in delivering ships and submarines out of new construction and repair availabilities, and NAVSEA absolutely owns this mission. Admiral Downey and his executive director, Mr. Miller, released a strategic plan in December of last year outlining those 5 strategic priorities I outlined earlier, but they also challenged me as both the Chief Engineer and the Warfare Center Commander to further improve and optimize how NAVSEA delivers technology and engineering solutions to program offices, depots, and fleet customers in support of advancing those 5 priorities. NAVSEA 05 and the Warfare Centers are already well integrated in delivering engineering solutions to our NAVSEA stakeholders and executing technical authority across warfighting disciplines. This intentional alignment only strengthens that integration. With that said, though, the enterprise metrics that are measured in ship deliveries and availability times show that we are off track and tell us that we must do things differently. It's imperative that we find every avenue for focus and collaboration between NAVSEA 05 and the Warfare Centers in collaboration with our industry partners to improve the shipbuilding outcomes as measured in ship deliveries, maintenance deliveries, and operational availability. As I mentioned, the Navy faces an urgent imperative to accelerate this capability delivery in an increasingly complex global security landscape. That requires a different approach to engineering delivery focused on speed, outcome, and effects. And so I didn't pre-plan this, but just prior to this talk, I was chatting with Don McCormick here in the audience, who is a great mentor in this space, and we were talking about the engineering kill chain. And so at NAVSEA, we are focused on shifting our mindset to treat engineering activities and product development in the same way warfighters treat their missions, by using this kill chain mentality, focused on outcomes and effect. At sea, our sailors execute what's known as find, fix, track, target, engage, and assess, a cool acronym that we love. I'm leaving out the acronym part. Sequence to neutralize an enemy, but their mission is to rapidly and effectively close the kill chain on the enemy. On the development side, the engineers, scientists, and technicians at NAVSEA can similarly close the engineering kill chain on technical challenges and capability gaps by using a step-by-step sequence or framework that outlines how a technical problem or vulnerability is identified, analyzed, exploited, and then neutralized or fixed. This engineering effort directly fuels the warfighter's success and ensures that the strategic resourcing and programmatic and acquisition cycles are tightly integrated with our development and operational phases. It's a holistic approach that allows us to work across all stakeholders, including industry, to accelerate delivery of superior capabilities. So you might listen to me say these words and say, well, this is just the systems engineering V, and we know how to do that. But I'll argue the difference here is the laser focus on warfighting outcomes and timeliness that separates this concept from standard peacetime approach to systems engineering that we're familiar with. It really just comes down to thinking and acting differently. So I'd like to take a minute and give a couple examples, a few minutes quite honestly, to give a couple examples of what tight collaboration between the warfare centers and program and technical authorities supported by our industry partners can deliver using this engineering kill chain mentality. So first, the Red Sea. Recent events in the Red Sea have underscored the critical importance of our work and what success looks like. Since October of 2023, Navy strike groups have successfully defended against hundreds of Houthi anti-ship ballistic missiles, anti-ship cruise missiles, and one-way attack drones. This is the result of a highly integrated and mature team that includes the Acquisition and Program Authority, PEO Integrated Warfare Systems, and their industry partners, the Warfare Centers, in this case, Naval Surface Warfare Center Dahlgren Division, with its exquisite facilities, modeling and simulation tools, and expertise. The Technical Authority, my Combat Systems Design Integration Managers and Technical Warrant Holders, and the Tactics Development House, or Surface and Mine Warfare Development Center, or SMWDC in this case, all aligned and working together towards a better outcome. Because of this close coordination and unity of effort, we've proven that we can rapidly collect the engagement data, return it to the lab, analyze it, update the combat system code, certify it, and deliver it over the air with new tactics to the ship in a matter of days. Not once, but continuously throughout a strike group deployment. All while maintaining technical rigor to ensure that the updated Aegis software is certified, free of bugs, and performs as originally designed, giving the crew full confidence in its reliability. I'll add that this tight learning cycle and capability delivery is enabled by a robust data strategy and digital engineering practices, which is also a foundational requirement and a NAVSEA priority. So I get lots of feedback on technical warrant holders in my day job as the chief engineer, but in this case, the feedback that I get is universally positive in that the NAVSEA's technical experts are an integral and important part of this success. And the facilities and expertise in the Warfare Center are the critical enablers that are enabling this process. So these engagements underscore the Navy's adaptability and effectiveness in a high-intensity conflict against even against technologically asymmetric threats. These lessons learned have informed improvements in naval tactics, weapon effectiveness, logistics, and overall air defense strategy, and enhancing future preparedness for more complex threat engagements. It's also a reminder that the Navy's technical enterprise must be able to respond in real time. Feedback from the fleet needs to loop quickly into our design, sustainment, and modernization decisions, and we're actively working to shorten that cycle. I think that we have more opportunity to ruthlessly focus on Navy and NAVSEA priorities and collaborate even closer across programs, operational and technical authorities, enabled by our Warfare Center enterprise to deliver improved acquisition and sustainment outcomes. And this is my mission as both NAVSEA 05 and the Warfare Center commander. So the Red Sea is a good example of this engineering kill chain approach in wartime. I'm going to pivot to a second example here, which is on a slightly longer but still accelerated and very relevant timescale. And that's how we're aggressively operationalizing and scaling emerging technologies like additive manufacturing to drive better shipbuilding and repair outcomes. Last November, the Navy issued a strategic plan, an advanced manufacturing strategy that focused on 3 lines of effort. The first line of effort was focused on industry and harnessing cutting-edge commercial capabilities for strategic advancements and empowering industry to swiftly integrate additive capabilities. LOE 2 was about modernizing our organic depots and empowering our waterfront maintenance organizations to deliver solutions. And LOE 3 was strengthening warfighter self-sufficiency at the point of need by deploying additive manufacturing capabilities to the fleet on our ships. So to go into a little bit more detail about those, because I want to get this word out, and we're making a lot of progress, but on LOE 1, the industry front, to truly unleash the additive manufacturing at scale, we need to empower the supply chain to manufacture the parts we need by all means possible, including the legacy processes such as castings and forgings, but now unlocking the power of additive manufacturing. And to that end, NAVSEA, with the close partnering and investment from the Maritime Industrial Base Organization, is developing new additive manufacturing military standards for 11 new metal alloy material process combinations. These combinations account for over 75% of the parts that are driving long lead times and extended schedules. By qualifying the manufacturing process, legacy parts can be delivered with new manufacturing techniques without the need to requalify the part. in full form, fit, and function conformance without specification deviation. This is our North Star called parts interchangeability. We are pursuing this approach across all levels of applications and criticality, including moonshot efforts that include sub-safe hull inserts measured in thousands of pounds of weight and nuclear applications. We are conducting this development effort in concert with the OEMs and the newcomer additive manufacturing as a service providers via other transaction authority, such that when we complete this effort, we will not just have new military standards, but we'll have vendors who are qualified to the new standards and ready to deliver at scale. And I'm going to touch more on how we're doing that later. A recent success, so we're seeing many successes. Just one example of that is that NAVSEA just recently accepted delivery of 3 firefighting valves, 2 for the Virginia class and 1 that will be installed in Columbia class from their OEM supplier. These valves, produced using wire arc additive manufacturing with copper nickel alloy, successfully passed all standard conformance testing and will be installed shortly. As the Navy's first OEM delivered ship service ball valves of this type, this is a validation of that particular technology and the overall process. LOE2 is about the depots, and it's about installing additive manufacturing capability in our public naval shipyards and our regional maintenance centers, but also empowering them to solve problems locally and rapidly. In 2023, NAVSEA released guidance to allow installation of additively manufactured parts of any material for systems that carry little to no risk in the safety and operation of the ship. This removes barriers to widespread implementation of additively manufactured parts and improves operational readiness. As an example of that, Forward Deployed Regional Maintenance Center Detachment ROTA recently contracted with a local Spanish additive manufacturing vendor to fabricate a metal replacement part and then installed it on a forward deployed destroyer and reduced the legacy lead time for that part by over 80%. Line of effort 3 is about installing shipboard capability. If the normal supply chain via LOE1 and our depots and maintenance centers via LOE2 cannot deliver or meet the needs of our forward deployed forces, we're giving them the capability to solve their own problems by installing additively manufactured machines on board the ships. This OPNAV-funded program is installing polymer machines on destroyers and attack submarines and hybrid metal machines on aircraft carriers and amphibious assault ships. And to date, we have 13 machines installed in the fleet. The combination of forward deployed ships supported by the depots and RMCs, all with additive manufacturing capabilities, is a force multiplier. We're already seeing these benefits in action. Just recently, one of our forward deployed amphibious assault ships, equipped with a hybrid metal printer, made a left-handed thread adapter for the main engine fuel system on board another amphib similarly deployed, allowing them to maintain operational capabilities without flying CAS reps or enlisting shore support. Our foundational efforts are paying off, and we're seeing the rapid proliferation of parts and solutions. As of July this summer, over 52 metal parts have been installed across the fleet, 31 in our surface fleet, 17 on submarines, and 4 on aircraft carriers. At this point, polymer part installations are essentially too numerous to count. Additive manufacturing is just one example of how we're rethinking technical timelines and empowering our engineers, sailors, and Marines. Whether it's additive manufacturing or other manufacturing technologies like laser ablation and robotic welding, or digital initiatives such as model-based system engineering and digital twin, NAVSEA is committed to smart and technology-driven acceleration. Shifting gears now to our workforce, our people are our biggest asset. There's no engineering kill chain without the people. Much of the urgency to adopt and scale advanced manufacturing technologies is to increase our nation's shipbuilding capacity and support our constrained shipbuilding workforce. The majority of our Navy's shipbuilding and maintenance delays are correctly attributed to the fact that our national manufacturing workforce has collapsed from roughly 30% of Americans decades ago to roughly 11% today. At the same time, the Navy has embarked on its most ambitious shipbuilding program since the 1980s. A tremendous national effort to rebuild this workforce is underway, led by the Maritime Industrial Base organization. But it's not just blue-collar tradespeople we need to develop. We need to rebuild the national maritime engineering workforce. And to that end, NAVSEA, again in partnership with the MIB, is increasing focus on building the next generation of ship designers, structural engineers, component engineers, and other critical engineering disciplines needed across the maritime and munitions industrial bases. One example is reviving the NAVSEA Professors Program. So we are now again funding professors at the Navy's leading naval architecture and ocean engineering universities to expand new and relevant curricula, conduct applied research supporting the Navy's needs, and help build the bench that we, NAVSEA and industry, need to remain the strongest Navy in the world. Okay, pivoting now to, I was struck by Congressman Amo's historical relevance in talking about this region in his opening remarks. But these imperatives that we're working on today mirror those of the past, and we've seen as a nation, we've risen to that challenge before. During World War II, the U.S. recognized the technology imperative and the importance of bridging innovations out into the field in a very short period. They also realized that it required an unrivaled collaboration with academics addressing the problems of the day, government passing the baton, and industry delivering at scale. Here in Newport, our Naval Undersea Warfare Center Newport Division, or Newark Newport, partners maintain a history of innovation that stretches back 150 years with significant contributions to undersea dominance. It took fearless innovation 150 years ago to experiment with new charged warheads, to test spar torpedoes, and to share the waters with brand new self-propelled fish torpedoes. Imagine the innovation, courage, and resiliency required to develop the first depth charges, the first homing torpedoes, the first sonar transducers, and the first torpedo computerized fire control systems. What stands out is that many of these advances weren't simply evolutionary, but they were revolutionary and helped make the United States Navy what it is today. This tradition and commitment to innovation continues throughout the 10-division Warfare Center enterprise and its relationship with American industry. It's about teamwork. Within the Warfare Centers, we're investing in developing and adapting technologies, like I mentioned earlier, through our internal NICE funding. The Naval Innovation, Science, and Engineering effort is funding allocated specifically by Congress for the Navy to improve warfighting capabilities, including ship maintenance and ship repair capabilities. We must make the most of these funds, so once we develop something that's promising, we want to collaborate with industry to take it to the next level. We can't just match, but we have to outpace the rate of innovation of our peer competitors. And this can only be accomplished through continuous collaboration, including events like this one, where we share our ideas and priorities, and through innovation where we take this new knowledge and apply it to research for fleet needs and demonstration through events like advanced naval technology exercises. Here in Rhode Island, the Undersea Technology Innovation Consortium, saw them downstairs yesterday, is a national network of resources that has driven successful opportunities for prototyping undersea capabilities. With over 300 members nationwide representing large and small businesses, nonprofits, and academic organizations, UTIC facilitates innovation through communication and collaboration with industry, academia, and the government. Just to make the connection again, I've spoken at UTIC Industry Days in the past in my role as program manager for unmanned systems, so quite familiar with that. But a few years ago, under that same program, you were briefed on the need to replace the aging Mark 30 anti-submarine warfare training target with a new Mark 66 heavyweight undersea training target. The Mark 30 has been in service for over 50 years, and the program office explained how they need a significant performance enhancement and set out to find, assess, and field new technology rapidly. As a result of that UTIC collaboration and innovation, the PEO, Admiral Doug Adams, friend of mine, just recently authorized a program office to award contracts for 4 Mark 66 heavyweight undersea training targets and the integrated logistics support, including technical manuals and maintenance documentation. So that's a great local example of that collaboration and innovation using OTA. Another is the Maritime Sustainment and Technology and Innovation Consortium, or MISTIC, that has enabled much of the progress in advanced manufacturing that I spoke about earlier. It's a collaborative effort focused on developing innovative solutions for maritime sustainment, addressing current and future security threats in maritime environments. It's a consortium of over 300 traditional and non-traditional defense contractors, large and small businesses, and academic institutions, all working under other transaction authority with the Naval Surface Warfare Center, Philadelphia Division. These collaborations are exactly what the nation needs to truly advance our Navy and future force. We have heard this call to action. The recent reconciliation bill included significant funding measured in billions of dollars to scale many technologies, including unmanned, as some of you know, near and dear to my heart. And in that regard, the Navy just last month released a solicitation seeking industry input, again using other transaction authority, in order to go fast and leverage industry solutions for support of the Modular Attack Surface Craft program. And so we're encouraging our industry partners to engage with these transformative initiatives and collaborate with us to shape the future. As the Deputy Commander at NAVSEA, I'm intently focused on the critical role that our engineering community and the warfare centers play in advancing NAVSEA's enterprise strategy. The fleet depends on NAVSEA's engineering excellence to get the Navy ships and their warfighting systems designed, delivered, and sustained to meet global national security requirements. NAVSEA 05 and the warfare centers are dedicated to ensuring our Navy remains the most technologically advanced in the world, and we're building on a proven foundation of military standards, embracing innovative manufacturing technologies, and investing our people. We've also laser focused on closing the gap between design and delivery, between fleet feedback and engineering response. Through better integration, digital tools, and technical leadership, we're strengthening our ability to deliver warfighting readiness at pace. We are committed to providing our sailors with the tools they need to succeed today and in the future. I look forward to meeting this challenge with all of you and with